When we get out our scatter plot, what we want to be able to do is describe it, to describe what we're seeing in the relationship between the two variables. So there's a few overall patterns that we could see. There are linear relationships, which is when we see this scatter plot come out, it's that the relationship is roughly like a line. It won't be exactly a line, or usually it's not exactly a line, but it roughly fits the look of a line. For curved data, it would have some sort of curved trend to it, so maybe something like this. And then with no pattern, that just generally looks kind of like a blob, just a blob of dots, but there's no real trend of increasing or decreasing. Now, when we work through our data, we want linear. The title of this section is linear regression. We want to work with linear data. So we're actually going to have these kind of conditions that we check. And one of the conditions is that when we get out this scatter plot, it has to be roughly linear. If it's curved, with the no pattern, we could technically look at it. It just won't be very interesting data. But especially if it's curved, we want to be really careful about when we get to using an equation of a line and talking about correlation. Those two pieces just don't work with curved data. So when we make our scatter plot, we want to see something that's roughly linear, or maybe it just doesn't have any pattern to it at all. Now, when we get out this scatter plot, and now what we're going to focus on is just linear data. So these next ones, we only want to look at linear type data and how we could start describing it. So there could be direction to it. And with that direction, it could be positive. So positive is going to be an increasing trend. So maybe something like this. The idea being that as you move to the right, our outputs are increasing. Negative would have a decreasing trend. So something like this, that as we read left to right, the outputs get lower and lower. Then there is the neither, which I realize I wrote no pattern there, but neither is going to be just like the blob that we see up above there. So there's not really any direction to it. It's just kind of all over the place. What you could also think about here is as we start to visualize this line that goes through the data, like for this first graph here, I could kind of imagine this line fitting the data. And for that second one, I could visualize this line fitting the data. The direction relates to the slope of the line. So with that positive one, that line would have a positive slope. And then for the negative one, that would have a negative slope. When we have the graph in neither, when we try to graph a line that fits the data, it ends up just being this horizontal line. So again, it's not really telling us much there. But then as soon as we can see direction, what we could do is start to think about strength. So let's say we looked at a positive linear scatter plot. If it is a strong positive linear scatter plot, what we might see is something maybe kind of like this, where there isn't much variability to the dots. They're pretty close by. If I visualize this line going through the data, everything's sticking really close by that line. So if we have that line, that relationship between the line and the scatter plot is really strong. Whereas, in fact, I'll even draw that same line. If we had a scatter plot that had moderate strength to it, what we would end up having is just a little more scatter to the outputs. So it'd still look linear, but there might just be a little more variability to the outputs. And then a weak relationship will just kind of be all over the place. It comes through definitely with the scenarios where we have no pattern or neither direction. But let's say we had our line and a weak relationship would just be all over the place. So it's that even if we could draw that line there, the relationship between that line and the data is very weak because they're just not really relating to each other. So that's how we'll talk about strength. It's basically how well is it fitting a line. And then there's two pieces that we want to be careful of. We want to be careful of outliers, which will be the scenario where, say, we have our scatter plot and maybe it looks kind of moderate or strong, but we can see our linear relationship, and then we have one, or we could have a few dots that separate from everything else. So that outlier we want to be careful of because it'll affect the things that we want to look at in these future videos of correlation and the equation of the line. It'll change those and it'll have a big influence. So we want to be careful of these outliers and whether or not we should include them. Maybe it's an important data value. Most often it's that extreme scenario, or maybe it was an error in input. We want to be careful of those outliers. And then for groupings, we want to be careful of these as well, where we see this linear trend and then the data changes and has some other trend. And it could also be linear. But when our data changes trend, it means there's probably subgroupings within our data. And what we should do is figure out what that subgrouping is and start separating up the data. So what we'd want to end up doing is looking at these graphs individually, like just look at this first subgroup and analyze that, and then have the second subgroup and analyze that separately. But you don't want to analyze it all together at once. So in terms of when we first get out our scatter plot, what we want to do is be careful of these, look for outliers, look for groupings, because if either's happening, we might want to look at adjusting our data. And then what we want to do is check the form of our scatter plot and make sure it is linear. We want to avoid anything that's curved. And then from there, what we can start to do is make our description. In our description, what we'll do is it should be linear, and then from there, describe the direction and the strength, which we can get from the visual of the data. What we're going to talk about next is correlation, where we'll actually have a numerical value that will help tell us what scenario we have. Is it positive or negative? Is it strong, moderate, or weak?